Okay, some of the things that we always need to do is to process the data. There are different ways of doing it, but the final product is to identify those that look like this. You can make these figures in the end. So what do we have here? We have atomic force microscopy images at different stages. We also have Raman imaging, Raman spectra, and even AFM in 3D perspective. The question is, how do we get to that from the raw data? There are even other examples, like the same ETX zones, how to get to this kind of figures. This is close to the final product of the figures we need for papers. Okay, let's start with the how do we get to this? First of all, we have the data in this software is by NTMDT. For example, I want to process this data. This is a Raman map. And it's very easy, very basic. First of all, you need to know what you have on the same page. I already know what I have here. It's flake function lines, MS2 flake on ITO, function lines with silver and for MBT. Yeah, I could do this one first. Fortunately, this Russian software is a headache to work with. It gives tons of errors. When it works, it's 50-50 chance that it's going to work. Okay, what I'm going to do. I know what is a molecule. So a Raman map consists of different pixels, and the spectra is measured at different pixels. And here is the whole information. This is what is called a hyperspectral Raman map. What we're interested in is to know the distribution of different parts of the components that are on this sample. I know that these low frequency modes are due to the two-dimensional layer that we're studying, and these high frequency modes are due to the molecule, originate from the molecule. So I want to make two maps, like the one I did here. You have one component is for the molecule itself, they may be, and one for the material, and then you can overlap. So how do we do it? First of all, I need to mark to tell the software this one, which one do I want. So I would need to be consistent. This MS2 has two modes, the A12G and A1G symmetry mode. So I will use the first one. And then select this peak and choose peak value. Notice that this Raman data was already measured without background. That's very important. That's on how you make the experiment. I don't need to process and subtract the background. But if you didn't measure your data properly, you will have a headache on how to use this software to subtract the background. Sometimes it works, sometimes it doesn't. And the bad thing is that if you don't know how to do it properly, you could modify the peak positions and the peak shapes. So that's why it's better if you execute the experiment properly and you take into account the background before you run the experiment. Okay, once you have there, you choose the peak position, the spectral region of interest, you press calculate. Depending on the version of the software, you will have different signals. So this one is here, it tells you what is peak position you're analyzing. And then you can play with intensity to see the regions you want to see. So I know that here is a molecule. There is a huge, if I go to the Raman map, I will see a huge part of the molecule there. The other thing is that I cannot see, this software is not very intuitive. I will need to remember from where this was taken. Now I will remember, but not, for example, now it's completely forgotten. I think it was this one, number 7. And once you come back here, for some reason, these guys decided every time you need to change to Raman shift. It's a Raman microscope with Raman spectrometer. By default, if I change from one side to the other, besides the annoying errors it gives, you have this. You cannot set by default, or I don't know how to set by default the one Raman shift. Hopefully those guys will be useful enough to change, to correct those mistakes. So you see from the Raman map, you can see the intensity here. It shows much higher, and that's exactly what this one is telling us. This map is telling us. Of course, you have this one also because there is a very strong intensity, and you can see that maybe even these peaks are being enhanced. This peak is being enhanced, or not. So you need to see the baseline because you can see higher intensity here because the background increase. It doesn't mean that you have a higher signal from the mode you want to see. But here there is no background. Here you have a lot in case of background because of the non-particle, but not here. So, and here you have low intensity, and here you don't have anything. Okay, so what do we do now? Once you have this mode and you export it, that's as much as this thing can do. So there are different ways you can use PNG and play in Affinity Designer. That's one way we could do. Yes, let's do it that way. It's not the usual way I do, but for the tools that we have here, and we don't have access to the other ones on this computer. So I will do it in one way that any of you can replicate. So I will go to the root data, exactly the same place where I got it. I also need to know the name of this file is S32 green after. So what I do is go to the file folder, to the folder where this data are, and green after for MBT. So it's this one. I will copy the file name, and this one is numbers. And this one. This is the intensity peak is E1G mode intensity. E1G. And I need to number 7. This is from number 7 from this data. So this is important because I need to know where that data is coming from. Once I process it and I need to make any change or to check something else, I need to be able from the file name to find where the original data are. So that's very critical. Once I have that, what is the result from that? You will have this image. Okay, this is more or less good, more or less because you have here the scale bars, the intensity bars. That's also good. Not so good because you have a pixel shape. I don't know how to change here. If you don't have a pixel, I don't want the pixel shape. I want Yep. Small thing here. No, I don't want a small thing. I want to see the raw data. But in here I don't see the option. Okay, we'll do with it. The second thing we need to do is to open an Affinity file, make a new one. I already have my predefined size. This is a typical size that works most of the time. Press print. I go here, enter the file. And also, if you need to see the quality of the file. So 70 kilobytes is not so good. You can see it here. The quality is very, very, very poor. So then I'm thinking this is the best way to do it, or yes, using this sheet is avoiding. Yeah, let's do this way to work. So once I have this one, the typical thing here, this file has all the dimensions I need. Yep. So I will do the same. Let's see if it works. I need the maps. I need the MX2 and I also need the molecule. So let's go back to 7. So we change. And the one that I want is this peak. This peak is from the molecule. The product of the molecule I want in this range. And then select and calculate. And you get this one. And you do exactly the same as before. Except I don't know if in this time I should do this again. Keep it full scale. Let's see what happens if I do this. Support engine. We have the file name of the last one, so I will keep it like this. And this is the DMAB intensity. It's a molecule. Save it. I want to check if this intensity now is not going to be saved there. Because if I come here and I try to see the rest of the intensity, I will not see it. So, for example, if I go on with exposure to see the rest, kind of. So let's see. This is how it looks like. Let's see if in reality it's like that. So you see how it looks like. Black. Yeah. Okay, maybe yes. Maybe it could work. Yeah, maybe it could work. Yeah, that could work. Then let's try the same here. The adjustment layer. Oh, sorry, that is one thing I need to do before. Always keep the original files. Make a copy of the original. Keep them there, because when you make modifications here, you want to come back to the original source to see the scale bars, especially the scale bars, because we're going to edit all that. We're going to make new ones. But to know the values, you need to come back to the original data. Okay, so those are the two. We need the idea then is to do this one. This is MX2, so the way to do it, and I know that this is not exactly the molecule, is because of the particle. It's not because of the MX2, it's because of the non-particle. Okay, so what do? There are different ways. Either I can edit the figure already, or I can crop all the sides and put the scale bars and color bars and recolor, play with the contrast, play with the color, make it nice. Yeah, I think I will start with this one. So I need to do all these things, and in which order, that's an important question. So I'm going to come here. I already know that there are some figures. Let me see, this is the same. So I will go here, go to the figures. Same EDX, no, I don't expect this one. So I will open the original that I already have. Oh, and what I'm gonna do is I'm gonna reuse the scale bars I already put there. So that's a good thing. Once you have made that, you have already available, because you should have access to some of these previous old files. You don't need to remake things, standard things like scale bars all the time. You just copy from the ones you already have. And the way to fix the scale bar is you come here, set it very carefully. Here you need to be as accurate as possible. And you come here to 1 key. So this is 1 micrometer. And now you can get rid of the XY scales. This one has exactly the same. So if you see they're the same size, so you can just copy, duplicate this scale bar and put that. So what I'm going to do is crop this side, and duplicate with this one. Well, you could do it now, or could do it later. But the good thing is if you do it now, you will see the guys will automatically align to the previous one you did. side, so we put it this side. Now that I'm here, I could even do this one to save the time that to move it around, to align it again, so I will already do it. This one will align to that. So we click it up, together, duplicate the scale bar, put it down. So you see it's there, and bring it to the front. Okay. Let's recolor. So in the original figure, almost two signal intensity is blue and the other one is red. So I need to make this one. This is super simple. Just come here and recolor and change to blue. Now, I told you that this part is because of the background. It's not really a signal coming from to the material. But you, before you take that, you modify. You need to make sure that that's the case. So you come here to the signal and you see how much intensity you have. But this is not intensity. This is like about 200, 100 something. You see the strong background, right? And if you come here, you will see the background is almost zero. And the peak intensity is only 50. So this is, so from here to here, more or less from here to here. So here is background, you have about 58 counts. And if you come here, you have about 73, 50 something. Yes, maybe there is some enhancement. Maybe there is some enhancement. It makes sense because you have a plasma particle here that will enhance the system. And you will see when we analyze the FM data why I'm a bit suspicious about that. That's real. It's because this particle is too large to allow the light to reach the nanoparticle, the MS2 below. And there is a lot of absorption by nanoparticle. The nanoparticle is shielding the MS2 below, but maybe the enhancement provided is so large that even for there is a loss, the enhancement compensates by that, and you still see some enhancement. Okay, what is the next one? So a new adjustment layer. I could even change exposure or the brightness. So I could start with exposure. And a bit to make it pop up. And there are other things you can play with, like this one. You can make it turn it until you have like typically adding or screen or lighting. Those help to see better the contrast. For the moment, I will not use it. I will leave it in normal, and then I will come here to the brightness and contrast. Increase a little bit, and you see that this applying. This is being applied to all of these. If I change this one, it's changing the other one, but that's not what I want. What I want is to apply only changes to this one. So you need to change the hierarchy of the changes you're making there and put it here. Now these changes will still no, it's this brightness. So I need to change it, but I already have a brightness there. No. Yes, there. So these changes will only affect that image. Okay. So increase a bit. What I want to know, this is saturated. I will not go to that. Anyway, we need the spectra from this location of interest to be extracted and to show, okay, if it's really an increasing background or not. So you don't show only the maps. Typically, you need to show both. You have different spots and you show the spectra. A map alone is not enough. Always keep that in mind. So once we did it, I'm happy with it for the moment. So let's keep it that way. Let's go now with the second one. And we do exactly the same as before. New adjustment layer, color. And this now is in red. I will also change the contrast. Explosion, let's go again. Do it like this. Well, actually, yes, like this will be good because this is at the noise level. So it will show already these black things. You're already at the noise level. You only have a signal from here, from this part. So exposure layer, adjustment layer. Okay, this is very simple. Here is where you have a signal. Now, I will not use this scale, this value here. This is enough by showing that we have this value. I will select these two and group them. That's critical because when you resize by any reason, the scale bar will resize also. Of course, you talking about resizing is very important that you resize in the right way. You never resize images in this way. You always need to keep the XY aspect ratio to 1. So the way to do it is like this. In the corner, never do stupid things like this or like this. You resize at the same rate the X and Y axis. So once you have these two, that's half the job done. If you see this one looks smooth, this one doesn't, and that's because of the noise level. If you're not satisfied with this, if you think, okay, that maybe we can make it nicer, you come here, that's the molecule, right? It's this molecule. Yes, that's a molecule. What you can do is to play with this background, something like that. And let's save it again. Export. And then you call it, this is DMV. Or high contrast, high work. Then that is here, comes here. And what I'm gonna do, I will not. You could either repeat apply all these filters, or what I prefer to do is if you select these filters. Okay, one way to do it. You can duplicate this one. Then put it to the top. And then you have this one. Then you can start moving shit here. Which one do you duplicate? I forgot. Oh shit. Although this is the one I want to use. For some reason this keyword is not there. Because I took it out. So what do we do? You start moving shit to this one. So it should be it didn't do the this one. It didn't do. That was let me see what happened there. I never tried that one before, but I don't know why it's not working. Okay, never mind. Oh, sorry. Remember also that before you do that, here, you need to keep the originals. Okay. And this is this one, so that one is this one. Okay, so passing things to this one. Also manually the cropping of the things that we don't need. No, I cannot do this now. Let's see. Can I do this one? Yes. Can I do this one? As you see, this is not going to be so precise if you don't use the figure guides for here. And they don't have exactly the same cropping. What you need to do is then ungroup this in this figure. So you can serve as a guide. Here. Now it's using it as a guide. But I'm not sure is this really, so you can see this one is a bit higher than the thing is cool about it. Yes. The mistake I did. It's better if you do this once for all the figures at the same time. So for example, here you see this is also not very good. You have this size here that you don't have there. So I will yes, there. Then let me move it until it's not there. Still not good. Ah, okay, I forgot to. Okay, let's continue then. I duplicate this one so I can pass the attributes, the primers and so on. You can either make it manually once again, or you can just pass them here. Which one is it? Oh, I'm modifying this one. Damn it. Again, this one doesn't matter. Oh, it was working. Okay, now as you can see, this one is we don't need it anymore. It's oversaturated. So I'm going to change that. Yes, I think this one looks better than that one. The color is okay. I do think yes, this one looks like too different from this one. This one is smoother, this one is not, this one is a little smoother. So to make it more homogeneous, to make it more in our harmony to images, is better if they have the same style. So this one will be better than this one. All right, there is this curve, which, okay, it's that one. I can just move it here, range, move to front. And since I already did this one, I will not throw it away. I will just keep it here in case I need it. I don't think I need it, just in case. Oh, something else that is very important is to save your projects. So this is called, I need to go to the one. So what is this? This is also, this is another one, but I will call this one reproducibility study. So once I got these two, the next one is to make the composite image. So as you saw, I just duplicate. And I want this one to put this one. It doesn't actually matter how I do it. I need to remember which filter how did I do that? One of the ways it did was to take this figure and add it to the other one. Yes, the red one on top of added to the blue one. Simple. So let's go take that one, add to the other one, and select. And that's what we got. And then you can go to, and that's it. Oh, there was one thing I didn't do. One mistake I did. I need this scale bar. I need a scale bar, right? From the side. This scale bar. I duplicate it, put it here, and I need to. Did I call this too? I will ungroup them. And select everything, group them again, and then I can do this scale. This, so that the scale bar also scales at the same rate as the rest of the image, and then it's still 1 micrometer. I could even take this micrometer here. I think that's what I did in the original. No, I am not add. I can leave it like that. Yes. So in this one, it has 0.15 height. I just want the width to change. I don't want everything else to change. Okay. Closer. That's it. That's how we have our image. Then, of course, you will need to come back here to come back to the original data and get the spectra. Get the spectra out from different regions. As you can see here, I have some 1, 2, 3, 4, some spectra. This one is 10. Some spectra I could use. Yes, actually, this one is maybe even better. 10 minutes to be mistake here. 20 micrometers. And 7 also has that resolution. Yes, 20 by 10. I don't know what is the difference between 7 and 10. Okay, let's see if we can check. Very likely is the filter I use. And I'm making this mistake because I didn't write it in the file name. I should have done that. And filter 2. No, what is the filter? 2. Okay, so this was filter 2, and I guess that this one was filter 1.5, higher intensity. Not so good. I should have started with highest intensity. Oh no, what is the difference between these two then? Okay, I need to check it out. So I have 1, 2, 3, 4, 5 spectra. And at the moment of making this experiment, I record some details about that. For example, yeah, 1, 2, 3. And I don't know why I have 5. Okay, this one I can already tell it was on the plate. And these spectra are a bit useless if I don't have the markers where I measure it. So you already know that this one is okay, got it. This one was in the middle. But I don't know where the other ones. Okay, I could guess where they were and compare us with the hyperspectral map, and also because of intensity. And maybe also, okay, I got it. I can't remember why we have 3. So I have these 3, but they don't match the pictures. Oops. Anyway, we already finished it with this part. The second part is to add the spectrum, either from this hyperspectral map. Then you take the curves and put them also here in Affinity Designer. You can play with them and get to this, like I did here. You can go to Origin, or you can use whatever software you use for processing the curves. Copy paste, and then you can also have these editable files that you can change the curves individually, like the thickness, the color, and so on. That's the next step.